My name is Namit and today we are doing our group project on ultrasound non-destructive testing. In this experiment we are going to do the non-destructive testing with the help of ultrasonic testing unit. Ultrasonic testing uses high frequency sound energy to inspect flaws, measure and characterize materials, etc. In non-destructive testing is used in the analysis techniques used in science and industry to evaluate the properties of the material, component or system without causing any damage. The terms non-destructive examination, non-destructive inception, non-destructive evaluation is commonly used in the technology because NDT does not permanently alter the article being inspected to a highly valuable technique that can save both money and time in the product evaluation, troubleshooting and research. The NDT method used in ultrasonic magnetic particle liquid penetrate radiographic remote inspection, and it is commonly used in forensic engineering, mechanical engineering, electrical engineering and system engineering, etc. And they are used in medicine also. So let's do our experiment.
My name is Gaganji Singh and we are going to show you about the ultrasonic non-destructive testing, and I'm going to tell you about the ultrasonic non-destructive testing unit, how to operate this machine. Ultrasonic testing uses high frequency sound energy to inspect flaws, measure dimensions, characterize materials, etc. A typical UD inspection system mainly consists of a pulsar or receiver. A pulsar or receiver means this part, and a transducer. Transducer is this part, and is a pulsar receiver is a electronic device that can produce high voltage electric pulses driven by the pulsar. The transducer generate high frequency ultrasonic energy. The sound energy is introduced and propagate through the material in the form of waves. When there is any discontinuity, such as any crack in the wave path, parts of the energy will be reflected back from the floor surface. The reflected wave signal is transformed into electrical signal by the transducer and is displayed on the screen. Location of a flaw can easily be detected by knowing the velocity of the sound and the testing material, thickness of the material, and the time taken by the sound wave to propagate from the transducer through the material and reflect from the flaw surface. Therefore, then the distance can be calculated. So with this technique we can calculate any crack, or we can measure any dimension using the ultrasound non-destructive testing, and in this testing the piece has no effect like other destructive testing method.
Hi, my name is Bisham Ambra. Today we are going to do the experiment, which is ultrasonic non-destructive testing, and here I'm going to explain the procedure and how we have to do this with some coupling oil and sample piece, and so we are going to perform this like. So I'm going to tell you the procedure that we have to perform this experiment. So like we have here transducer, and this is our flow detector machine. So the first step is to turn on the flow detector machine, and then we have given two samples. The one sample is for practice and with visible holes, and the other sample with the invisible holes, which we have to perform the experiment on. So first with the practice sample we have to apply some coupling oil on it, so air do not pass from the transducer and the surface of the steel. Okay. Like you can see here how we have to move our probe transducer over the sample, aluminum sample. So this is our display screen where we get the all the observations. So when it detects something, it will show the percentage above 50% over there. So when it's over 50%, we have to take the reading next to that reading, which will our vertical distance from that probe to the invisible hole. So when we get the vertical distance, so we can calculate the horizontal distance from any edge of the aluminium piece. From this, we can calculate from this side, or we can calculate from that side. Like here we can see that if this is our transducer and it reflects the ultrasonic rays. So this is our sample. If it does not detect anything, so it reflects back to the surface again on the top. So if it detects any crack, so it will reflect that, and we can calculate this distance d. So like when we do this experiment with our sample with invisible holes, these holes are all invisible, and we calculate the vertical distance by using the same method as I explained before. So this is our surface. This is the surface of our aluminium sample, which is with invisible holes. So this is edge A, and this is edge B. So this is a horizontal distance we calculated by the scale from edge A, or from edge A, and to the center of that probe we are using. So this is how we can perform this experiment.